There are planets where the idea of standing on the ground stops making sense. Not because they are distant or unexplored, but because the conditions that make a world feel stable, visible, and real simply are not there. Light does not behave the way it should. Surfaces do not remain solid. The sky does not change gradually. It shifts without warning or disappears entirely. On Earth, it is easy to assume that planets are places, somewhere you could stand, observe, and understand. Even if the environment is extreme, there is still an expectation that it follows rules that feel familiar, that there is a horizon, that there is something beneath you, that the world, however hostile, is still coherent. But most planets are not like that. They are not places in the way we imagine them. They are conditions. Systems where gravity, heat, pressure, and radiation combine in ways that do not produce anything recognizable. And when those conditions move far enough away from what we are used to, the result is not just a harsher environment. It is something that feels fundamentally wrong. Worlds where you cannot rely on sight, where the ground may not exist in any stable form, where the sky itself becomes unpredictable or even invisible. Places that do not just challenge survival, but challenge the way the human mind expects reality to behave. And once you move into that part of the universe, the question is no longer whether a planet is dangerous. It is whether it can even be understood at all. There is a planet where light arrives, and almost none of it returns. Not because it is hidden or distant, but because it absorbs nearly everything that reaches it. From a distance, it would not appear as a glowing sphere, or even a dim one. It would appear as an absence, a shape that only becomes visible because it interrupts the stars behind it, like something missing rather than something present. The planet is known as B. On Earth, even the darkest materials still reflect a small amount of light, enough for edges to form, enough for the eye to recognize shape. B goes further than that. It reflects less than 1% of the light that reaches it. The rest is absorbed into an atmosphere that does not behave in any familiar way. If you were close to it, the experience would not feel like standing in darkness. Darkness on Earth still has context, a sense of space, a gradual shift between light and shadow. Here, there would be none of that. Objects would not slowly emerge as your eyes adjust. They would simply not appear at all. And yet, this is not an empty or quiet place. The atmosphere is in constant motion, heated to extreme temperatures, filled with violent currents that never settle. Within that movement, there are brief flashes, sudden discharges of energy that illuminate parts of the planet for fractions of a second before disappearing again. For an instant, the world reveals itself. Then, it vanishes. What you would see would not be a continuous environment, but fragments. Disconnected glimpses of something vast, each one too brief to fully understand. The mind would try to piece them together, to build something stable from what little information is available, but it would never quite succeed. It would not feel like looking at a planet. It would feel like trying to understand something that refuses to be seen. Even its darkness is not what it first appears to be. Despite absorbing almost all incoming light, the planet is not cold or inactive. It is heated by its proximity to its star and by the constant movement within its atmosphere. Energy is being transferred, redistributed, and released at all times, just not in a way that can be easily seen. It still emits radiation, just not in wavelengths the human eye can detect. So while it appears almost perfectly black in visible light, it is still active, still glowing in a way that exists beyond perception. That is what makes it unsettling. It is not empty. It is not silent. It is not still. It is simply hidden. And that creates a different kind of problem, one that is not about survival, but about understanding. Because the human mind depends on sight more than anything else to interpret the world around it. It builds space from light, distance from contrast, structure from edges and boundaries. Remove those, and the world stops making sense. On Tres 2b, there would be no stable reference point, no consistent horizon, no reliable way to judge scale or distance. Even the brief flashes within its atmosphere would not help, because they would only reveal fragments, never the whole. You would always be missing something, and over time, that absence would become impossible to ignore, not just as a physical limitation, but as something more disorienting. The sense that there is a structure there, something vast and continuous, but one that can never be fully observed, never fully understood. A world that exists, but refuses to present itself as one. And once that idea begins to settle, it raises a quieter, more unsettling possibility. That this is not unusual. That there may be many places like this scattered throughout the universe, not hidden by distance or scale, but by the simple fact that they do not interact with light and with perception in a way that allows them to be clearly seen at all. And if that is the case, then the darkness of Tres 2b is not an exception. It is just one example of a much larger pattern. If Tres 2b is a world that hides itself from view, then the next planet does something far more direct. It does not obscure reality. It disrupts it. HD 80606b, which we will refer to as HD, follows an orbit that is unlike almost anything we are familiar with, stretched into an extreme ellipse that carries it from a distant, frozen state to a position dangerously close to its star. For most of its orbit, it exists far away, where temperatures remain relatively low and stable, but as it approaches the inner part of its path, everything changes in a very short period of time. The planet accelerates, falling inward, and the amount of energy it receives from its star increases rapidly, not gradually, but in a sudden surge that transforms the entire atmosphere. Within a matter of hours, temperatures can rise by hundreds of degrees. What was once a comparatively calm environment becomes something far more volatile as heat floods through the atmosphere and drives violent expansion. Winds intensify, pressure systems shift, and the structure of the atmosphere begins to distort under the strain. There is no slow transition, no extended build-up that might allow for adjustment. The change is abrupt, and it affects the entire planet at once. From a human perspective, the most unsettling part is not the temperature itself, but the lack of consistency. On Earth, even the most extreme environments follow patterns that can be anticipated. Day leads into night, seasons change over time, and even severe weather develops with some degree of progression. On HD, that expectation breaks down completely. The sky does not warn you. It does not gradually brighten or darken in a way that signals what is coming. Instead, the environment shifts with a speed and intensity that would feel almost instantaneous. There would be no stable sense of time. The planet's orbit dictates everything, and that orbit is not gentle or balanced. It is stretched to the point where the difference between one part of the cycle and another is extreme, creating a world that cannot settle into any consistent state. Conditions are either relatively calm or overwhelmingly intense, with very little in between. And the transition from one to the other happens so quickly that it would feel less like a natural process and more like a sudden failure of the environment itself. The atmosphere does not simply heat up. It reacts. Energy moves through it in waves, expanding and shifting the structure in ways that would be difficult to predict or understand from within. What might appear stable one moment could become chaotic the next, not because something external has changed suddenly, but because the planet has reached a point in its orbit where everything is forced to respond at once. It is a world defined not by what it is, but by how quickly it can become something else. And that creates a different kind of instability, one that is not constant but cyclical. A planet that repeatedly moves between extremes, never remaining in one state long enough to feel predictable, never allowing the kind of continuity that makes an environment understandable. Each orbit is a reset, a return to conditions that cannot be controlled or avoided, only experienced as they happen. If the first world removed the ability to see clearly, this one removes the ability to anticipate, replacing it with something far less comfortable. A sky that can turn against you without warning, and a world where change does not arrive slowly, but all at once. If one world removes visibility, and another removes predictability, then there are places where the problem is not what is happening around you, but what is happening at the source of everything. PSR B1257 plus 12 is not a normal planetary system, because the object at its center is not a normal star. It is a pulsar, the collapsed core of something that once existed in a far more familiar form. A star that ended its life in a supernova and left behind something far denser, far more compact, and far less stable in the way it interacts with its surroundings. For simplicity, it helps to think of it simply as PSR, because everything that defines this system begins there. A pulsar does not shine in the way a typical star does. It rotates rapidly, emitting focused beams of radiation from its magnetic poles, sweeping those beams across space like a lighthouse. But unlike a lighthouse, what it emits is not light in any sense that would be harmless or even visible. It is intense radiation, concentrated and directional, moving outward in pulses that repeat with precise timing. The planets that orbit PSR exist within this system, which means they are not simply orbiting a star. They are orbiting the remains of something that has already destroyed everything around it once before. From a distance, the motion of the pulsar is almost mechanical in its precision. The rotation is steady, the pulses are regular, and the system appears stable in a way that feels almost artificial. But that stability hides the nature of what is actually happening. Each rotation sends out beams of radiation that sweep across the surrounding space, and any planet within that range is exposed to it repeatedly, with no way to avoid it. There is no day or night in the usual sense. Instead, there are intervals of exposure, moments when the beam passes over a given point, followed by moments when it does not, creating a rhythm that is not tied to light and darkness, but to radiation and its absence. The surface of a planet in this system would not experience a gradual change in illumination. It would experience repeated bursts of energy, arriving with a regularity that might initially seem predictable, but would never feel natural. And the energy involved is not something that can be ignored. The radiation emitted by a pulsar is powerful enough to strip away atmospheres, to alter the structure of matter at a fundamental level, and to continuously reshape the environment of anything that remains in orbit around it. Over time, any planet in such a system would be forced into a state of constant exposure, its surface altered again and again by forces that do not diminish or stabilize. It is not just the intensity that makes it unsettling. It is the fact that this system exists at all. Because for these planets to be there, they must have either survived the explosion that created the pulsar or formed from the remnants that were left behind. Either possibility suggests a process that is far removed from anything that occurs in more stable systems where planets form gradually from a disk of material around a young star. Here, everything begins with destruction, and what follows is a kind of reconstruction that takes place under conditions that are far more extreme. The result is a system that feels inverted, a place where the central object is not a source of stability, but the remnant of a violent ending, and where the planets that orbit it do so in an environment defined by what has already happened, rather than what is yet to come. Every orbit, every rotation, every pulse is a continuation of that event, a reminder that the system itself is built on the aftermath of something far more destructive. A world orbiting a dead star is not just extreme. It is a place where the past has not finished happening. If the previous system is defined by what remains after destruction, then Kepler 78b represents something else entirely, a world that has not been torn apart in a single moment, but one that exists in a state where it is never allowed to settle at all. It orbits extremely close to its star, so close that what would normally be considered a stable surface cannot exist in any familiar way. The constant exposure to intense heat means that the outer layers of the planet are not solid in the sense that we understand. Rock does not remain fixed, does not hold its shape over time. Instead, it behaves more like a fluid, shifting and moving under conditions that prevent it from ever cooling or stabilizing. From a distance, the planet would appear to glow. Not because it reflects light in the usual sense, but because its surface is heated to the point where it emits its own. Large regions of molten material stretch across it, forming what could be described as oceans. But these are not oceans in any sense that feels calm or contained. They are constantly in motion, driven by temperature differences between different regions of the planet, flowing slowly but continuously, reshaping the surface without ever reaching a fixed state. There is no solid ground to rely on. Even where the surface begins to cool slightly, it does not remain that way for long. Heat is constantly being redistributed, carried through the planet by convection and radiation, ensuring that any temporary stability is short-lived. What might feel like a surface in one moment could begin to soften, to shift, to lose its structure as conditions change, removing any sense of permanence. Time itself would feel different here. Not because it moves differently, but because nothing around you would remain consistent long enough to measure it against. On Earth, time is often understood through change, but change that follows patterns. Day becomes night, seasons cycle, environments evolve in ways that can be tracked and predicted. On Kepler 78b, change is constant, but it does not follow a comforting rhythm. It is continuous, driven by conditions that never ease, never pause. The planet is also likely tidally locked, which means that one side is always facing its star, while the other remains in relative darkness. This creates a sharp contrast between regions, with one side exposed to constant intense heating, and the other cooler, but still far from stable. Between these extremes, there would be zones where material flows from one side to the other, transferring heat and energy across the planet in slow, persistent currents. It is not a quiet process. Energy is always moving, always reshaping the environment, ensuring that nothing remains as it is for long. The idea of a fixed landscape, something that can be observed, mapped, and understood, breaks down completely. Instead, the planet exists in a state of continuous transformation, where the distinction between solid and liquid becomes less meaningful, and where the concept of a stable surface begins to lose its relevance. From a human perspective, this creates a different kind of unease. Not the sudden violence of a world that changes without warning, but the absence of anything that can be relied upon at all. There would be no point at which the environment feels settled, no moment where the conditions pause long enough to be understood as they are. Everything is always in motion, always shifting, always becoming something else. It is a world that never holds its shape. And in that sense, it is not just extreme. It is unfinished. If Kepler 78b is a world that never settles, then WASP 76b takes something far more familiar and turns it into something unrecognizable. At a distance, it might not seem especially different from other large gas giants that orbit close to their stars. But what sets this planet apart is not just its temperature or its proximity, but what that heat does to the materials within its atmosphere. The conditions are extreme enough that metals, substances that on Earth are solid and stable, do not remain that way. They are heated to the point where they begin to behave like gases, rising into the upper layers of the atmosphere as vapor. Iron exists in the sky of this planet, not as particles, not as dust, but as a gas, carried by powerful winds across a world that is divided into two very different regions. Like many planets that orbit close to their stars, WASP 76b is likely tidally locked, with one side permanently facing the star, exposed to constant and intense heat, while the other remains in relative darkness. This creates a stark boundary between the two, not a gradual transition, but a shift between extremes. On the day side, temperatures are high enough to keep iron in a vaporized state. The atmosphere is thick with it, moving slowly across the planet, carried by currents that redistribute heat from one side to the other. But as this material is transported toward the night side, the temperature begins to drop. Not enough to create anything that could be described as cold, but enough to change the behavior of what is in the atmosphere. The iron condenses. What was once an invisible vapor begins to form into droplets, falling through the atmosphere in a process that mirrors rain, but only in structure, not in substance. This is not water returning to the ground. It is metal, cooling just enough to fall out of the sky before eventually being carried back toward the hotter regions, where the cycle begins again. It is a closed system, driven entirely by heat. From a human perspective, the most unsettling part is not the presence of iron itself, but how familiar the process would seem at first. There is a day side and a night side. There are atmospheric currents. There is something that resembles weather. But each of these elements behaves just differently enough to make the entire system feel wrong. The patterns are recognizable, but the substance is not. Rain is something that suggests renewal, a cycle that supports life, something that falls and is absorbed and returns again. On WASP 76b, that idea is stripped away. The cycle still exists, but it serves no purpose beyond maintaining the conditions that created it. There is no balance being achieved, no environment being sustained, only the continuous movement of material between two extremes. The boundary between the day side and the night side would be one of the most extreme transitions imaginable. A region where temperature, light, and atmospheric composition all shift in ways that would be impossible to ignore. The sky itself would change character depending on where you are, not gradually, but with a clarity that reflects the underlying structure of the planet. One side dominated by heat and motion, the other by condensation and return. And yet, neither side offers anything that could be considered stable. The entire planet is defined by this exchange, by the constant movement of material that never settles into a final state. There is no region that escapes it, no location where conditions pause long enough to create something consistent. Everything is part of the same cycle, driven by heat, maintained by motion, and repeated without variation. It is not just a world where the environment is hostile. It is a world where something as simple as rain has been transformed into something unrecognizable, where a familiar process has been rewritten into a form that feels almost mechanical, stripped of meaning, reduced to function. And in that sense, it creates a different kind of discomfort, not because it is chaotic, but because it is so precise, so consistent, and so completely detached from anything that resembles the systems we associate with life. If WASP 76b takes something familiar and reshapes it into something unrecognizable, then Gliese 1214b removes something even more fundamental. It removes the idea of a surface. This planet is often described as a water world, but that description can be misleading because it suggests something that feels open, something that has a boundary between ocean and sky, something that can be understood in terms of depth and distance. What likely exists here is something far more continuous, a planet where water, heat, and pressure combine to create an environment that does not divide neatly into layers. There may be no solid ground at all. Instead, the planet is thought to be made up largely of water in different states, compressed under such extreme pressure that it behaves in ways that do not occur naturally on Earth. The upper layers could consist of thick clouds and dense vapor, while beneath that the pressure increases rapidly, forcing water into forms that are neither liquid nor solid in the way we understand. It becomes something else, structured by conditions that reshape its properties at a fundamental level. From above, there would be no clear indication of what lies below. The atmosphere would obscure any sense of depth, creating a uniform, featureless appearance that offers no reference point. There would be no coastline, no variation in terrain, nothing to suggest where one region ends and another begins. Just a continuous expanse, stretching in all directions without interruption. And beneath that, the environment becomes increasingly difficult to define. Pressure builds quickly, far beyond anything experienced in Earth's oceans, compressing the water into denser and more structured forms. Heat from the planet's interior interacts with this pressure, creating conditions where the distinction between different states of matter begins to lose clarity. It is not simply deep water. It is an environment where water exists in phases that do not behave in familiar ways, falling layers that are stable only under these extreme conditions. There is no point at which you would reach something solid. No boundary where the ocean ends and the planet begins, because the ocean is the planet, extending downward into states that become progressively less intuitive, less recognizable, and more difficult to describe. The idea of reaching the bottom becomes meaningless, replaced by a gradual transition into something that cannot be easily classified. From a human perspective, the absence of a surface creates a different kind of disorientation. On Earth, even in the deepest parts of the ocean, there is always an understanding that there is a limit, that somewhere below there is ground, something that defines the boundary of the environment. On Gliese 1214b, that expectation would not hold. There would be no final point of reference, no definitive boundary that signals the end of one thing and the beginning of another. Everything would feel continuous. Above and below would begin to lose their meaning, replaced by gradients of pressure and temperature that shift gradually but relentlessly. There would be no horizon in the usual sense, no stable frame of reference to anchor perception, just an environment that extends without interruption, becoming denser, hotter, and more unfamiliar the deeper it goes. It is not just an ocean. It is a world where the concept of separation between sky and sea, between surface and depth, has been removed entirely. And without that separation, the idea of a place, something that can be located and understood, begins to fall apart. If Gliese 1214b removes the idea of a surface, then TOI-178 challenges something less obvious, but just as fundamental. It challenges the expectation that planetary systems should feel irregular, shaped by gradual processes that produce variation, imbalance, and unpredictability. On Earth, and within our own solar system, orbits are stable, but they are not precise in any way that feels engineered. Each planet moves according to gravity, but the relationships between them are not exact, not locked into patterns that repeat perfectly over time. TO1 78 is different. It is a system where multiple planets are locked together in a chain of orbital resonance, moving in a pattern so precise that it can be described almost like a rhythm. Each planet completes its orbit in a time that relates directly to the others, forming a repeating sequence that maintains itself with remarkable consistency. It is not random, and it is not approximate. It is exact. From a distance, this creates a system that feels ordered in a way that is difficult to ignore. The motion of the planets is not just stable, it is synchronized. As one completes a certain number of orbits, another completes a different number, but always in a ratio that repeats. The entire system moves like a coordinated structure, each part connected to the others through gravitational relationships that keep everything aligned. There is nothing chaotic about it. And that is where the discomfort begins, because the expectation is that natural systems, especially on this scale, should contain irregularities. Small deviations, gradual shifts, imperfections that accumulate over time. But here, those irregularities are suppressed by the very structure of the system. The gravitational interactions between the planets do not lead to instability. They maintain the pattern, reinforcing it, ensuring that the rhythm continues. It would feel less like observing a collection of planets and more like observing a mechanism. Something that has been set into motion and continues to operate without variation, without drift, without the small inconsistencies that make systems feel natural. Each planet follows its path, not independently, but as part of a larger sequence where its motion is tied directly to the others. From a human perspective, the unsettling part is not danger, but precision. There is no immediate threat, no extreme environment that would prevent survival in the same way as the previous worlds. Instead, there is a system that behaves too perfectly, too consistently, creating a sense that what is being observed is not just governed by physics, but constrained by it in a way that feels unusually strict. Time itself would feel structured differently here, not because it changes, but because the repetition is so exact that it becomes impossible to ignore. The cycles would not drift, would not slowly evolve into something new. They would repeat, over and over, maintaining the same relationships, the same timing, the same sequence. It is a kind of order that removes variation. And without variation, something else begins to fade. The sense that what you are observing is evolving, changing, or moving towards something new. Instead, everything is already set, already defined, already locked into a pattern that does not need to adjust or adapt. It is not unstable. It is fixed. And in that sense, it creates a different kind of unease, not from what might happen, but from the sense that nothing will. A system where everything moves, but nothing changes. If TOI 178 represents a system defined by precision and structure, then rogue planets represent the complete absence of both. These are planets that do not orbit a star at all. They exist without a central point of reference, without a source of light, without anything that defines a stable cycle of day and night. They are not part of a system in the usual sense. They drift. Most planets form around stars, held in place by gravity, moving along paths that can be predicted and understood. Rogue planets have lost that connection, either ejected from their original systems through gravitational interactions or formed in isolation from the beginning. In either case, the result is the same. A world that moves through interstellar space alone, without anything to anchor it. There is no sunrise, no gradual shift from darkness to light, no rhythm that marks the passage of time in a way that can be easily perceived. The sky would not change in any meaningful way. Stars would remain fixed in their positions, distant and unchanging, offering no sense of movement or progression. Without a nearby star, There is nothing to illuminate the planet's surface in a way that creates contrast or depth. It is not just dark. It is consistently, unchangingly dark in a way that removes the idea of time passing through light. On Earth, even in the deepest night, there is an expectation that morning will come. On a rogue planet, that expectation does not exist. There is no cycle to return to, no transition waiting to happen, only a continuous state that does not shift. And yet, these planets are not necessarily frozen solid. Some may retain heat from their formation or generate internal heat through radioactive decay, creating environments beneath their surfaces that remain active. Beneath layers of ice or rock, there could be movement, even liquid reservoirs, hidden from the surface by thick insulation. But none of that changes what it would feel like to exist on the outside, because from the surface, there is no indication of any of it. No light, no variation, no signal that anything is happening at all. The environment would feel static, not because nothing is occurring, but because nothing is visible. The connection between observation and reality would weaken, leaving only the immediate surroundings as a reference, with everything beyond that fading into a uniform darkness. Direction would begin to lose meaning. Without a central star, there is no obvious point of orientation. No east or west, no rising or setting point to define movement. Even the concept of location becomes less clear, because the planet itself is not moving around anything in a way that can be easily perceived. It is traveling, but that movement has no visible effect on the sky. It is motion without reference, and over time, that absence would begin to affect perception in a way that is difficult to fully describe. The human mind expects change, expects progression, expects some indication that time is moving forward. Without those signals, the environment would begin to feel disconnected, not just from the rest of the universe, but from the idea of continuity itself. It would not feel like being on a planet. It would feel like being isolated within something that does not acknowledge your presence at all. A world that exists, but does not participate in anything larger. And in that sense, it is not just distant. It is alone. If rogue planets represent isolation, then Kelt 9b represents the opposite extreme, a world that is so close to its star and so overwhelmed by it that it begins to lose the ability to remain a planet at all. This is one of the hottest planets ever discovered, with temperatures high enough to do more than melt rock or vaporize metals. The energy it receives from its star is so intense that it begins to break down the very structure of matter in its atmosphere. Molecules do not remain intact. They are pulled apart, reduced to their constituent atoms, unable to hold together under the constant bombardment of radiation. It is not just hot. It is destructive at a fundamental level. The star it orbits is itself unusually energetic, emitting large amounts of ultraviolet radiation that floods the planet continuously. Because of this, the atmosphere of Kelt 9b is not stable. It is being actively stripped away, heated, expanded, and pushed outward into space. The boundary between the planet and its surroundings becomes less defined as material escapes, forming a kind of extended envelope that trails behind it. From a distance, it would not appear as a clean, contained sphere. It would look distorted, its outer layers stretched and thinned, no longer held tightly in place by gravity alone. The idea of a stable atmosphere, something that surrounds a planet and remains with it, begins to break down. Instead, the planet is in a constant state of loss, gradually shedding parts of itself as it continues its orbit. There is no recovery from this process. It is not cyclical, not something that resets or stabilizes over time. It is continuous. With each orbit, more material is lost, more structure is broken down, and the planet moves incrementally closer to a state where it can no longer maintain what defines it as a planet. From a human perspective, the most unsettling aspect is not the heat itself, but the sense that nothing can remain intact. On Earth, even in extreme environments, there is still an expectation that matter behaves consistently. Objects hold together, materials retain their structure, and the environment, however hostile, follows rules that allow for some degree of stability. On Kelt 9b, those rules are pushed to their limit. The environment does not just damage or erode, it dismantles. The atmosphere cannot protect itself. The materials within it cannot resist what is happening to them. Everything is subject to the same continuous breakdown, driven by energy levels that exceed what the planet can contain. There is no balance being maintained, no equilibrium being reached. Only a slow, persistent unraveling. It is a world in the process of coming apart. Not suddenly, not violently in a single moment, but steadily, with each orbit reinforcing the same outcome. A planet that cannot hold on to itself, existing in a state where its identity is gradually being stripped away. And in that sense, it represents a different kind of ending. Not one defined by a single event, but by a process that never stops, where the line between what the planet is and what it is becoming grows thinner over time, until eventually there may be nothing left to define at all. If Kelt 9b is a world that is being slowly dismantled, then HD 189733b represents something that is far more abrupt, a place where the environment itself is in constant motion, driven by forces that do not allow anything to remain still for long. This planet is known for its atmosphere, not because of what it contains, but because of how it moves. The winds here are among the fastest ever observed on any planet, reaching speeds that far exceed anything experienced within our own solar system. These are not occasional storms or isolated events. They are continuous, sustained flows of gas that move across the planet with incredible velocity, reshaping the atmosphere in real time. From a distance, the planet would appear active, its upper layers constantly shifting, patterns forming and dissolving as the winds carry material from one region to another. But from within that atmosphere, the experience would be very different. There would be no stillness, no moment where the environment pauses. Everything would be in motion, all the time. The reason for this lies in the temperature differences across the planet. Like many close-orbiting worlds, HD 189733b is likely tidally locked, with one side permanently facing its star and the other turned away. This creates a strong contrast between regions, driving powerful currents as heat is transferred from the day side to the night side. But unlike more stable systems, where this transfer creates patterns that can settle into some form of equilibrium, here the process is far more extreme. The atmosphere is pushed into a state where movement becomes the dominant feature. Winds do not simply circulate. They accelerate, driven by pressure differences that are constantly being reinforced by the uneven heating of the planet. The result is a system where speed is not an exception, but the default. Gas is carried around the planet in continuous streams, moving so quickly that any local structure is immediately disrupted. Cloud formations would not linger. Any attempt at stability would be short-lived, as the winds tear through the atmosphere, redistributing material faster than it can settle. The sky would not have fixed patterns, no consistent formations to observe over time. Instead, it would be a constantly shifting field, where shapes emerge briefly before being stretched, broken apart, and replaced by something else. From a human perspective, the unsettling aspect is the absence of stillness. On Earth, even in the most extreme weather systems, there are moments of relative calm, periods where the environment resets before the next change. On HD 189733b, That pause does not exist. Movement is continuous, and it is fast enough that it dominates everything else. There would be no sense of shelter. Not because there is nowhere to go, but because the environment itself does not allow for anything to remain protected. The winds would not simply pass through. They would persist, carrying energy across the planet in a way that prevents any region from becoming stable. It is not chaos in the sense of randomness. The system is driven by clear physical processes, by heat, pressure, and rotation. But the result feels overwhelming because it never slows down. There is no reduction in intensity, no gradual easing of conditions. Only continuous motion, sustained by the same forces that created it. It is a world where the atmosphere never rests. And in that sense, it removes something that is often taken for granted. The idea that, at some point, things will become still. If HD 189733b is defined by constant motion, then GJ 367b represents something quieter, but no less extreme, a world shaped not by violent winds or rapid change, but by conditions that are so persistent that they leave no room for variation at all. This is a planet that orbits very close to its star, completing a full orbit in just a few days, and as a result, it is almost certainly tidally locked. One side faces the star continuously, exposed to constant radiation and heat, while the other remains in darkness. But unlike some of the previous worlds, where extremes create dynamic systems of movement and exchange, here the defining feature is stability taken to its limit. The same side always faces the star. The same regions are always heated, always illuminated, always exposed to the same conditions without interruption. There is no rotation that brings relief, no cycle that allows the environment to reset. The distinction between day and night is not something that shifts. It is fixed in place, dividing the planet into two permanent states. On the day side, temperatures rise to levels that make the surface hostile, potentially hot enough to alter the structure of the ground itself, depending on the exact composition. Heat is not something that comes and goes. It is constant, reinforcing itself over time, ensuring that whatever conditions exist there are maintained without interruption. On the night side, the absence of direct radiation creates a very different environment, one that is cooler but not necessarily stable in a way that feels comfortable. Without a source of heat, the energy available to drive change is limited, and the environment could settle into a state that is static, unchanging over long periods. Between these two extremes there may be a narrow region, a boundary where conditions are less severe, where temperatures are lower than the day side but higher than the night side. This is often described as a possible habitable zone, a thin band where the balance between heat and cold creates something closer to what we recognize as stable. But even here, the stability is unusual. It is not maintained by cycles, not by changes that balance each other over time, but by the absence of change itself. The conditions do not evolve. They remain fixed, held in place by the planet's relationship with its star. From a human perspective, this creates a different kind of unease. Not because the environment is unpredictable, but because it is too predictable. There would be no passage of time marked by light and darkness, no shifting conditions to signal progression. The sky would remain the same, the environment would remain the same, and the sense of time passing would have to come from within, rather than from anything external. It would feel like being held in a single moment, a world where nothing changes, not because it cannot, but because the conditions do not allow it to. The planet is locked into its state, and everything on it would be subject to that same permanence. It is not a world of extremes in motion. It is a world of extremes that never move at all. If GJ367b is a world that has been locked into stillness, then WASP-12b represents something far less stable, a planet that is no longer fully able to hold itself together. It orbits extremely close to its star, closer than almost any planet should be able to exist without consequence. At that distance, gravity does not act in a balanced way. The side of the planet facing the star experiences a much stronger pull than the side facing away, creating a stretching effect that distorts the entire shape of the planet over time. This is not a subtle process. The planet is being pulled apart. Its outer layers are no longer held tightly in place, and material from its atmosphere is being drawn away, forming a stream that extends outward, connecting the planet to its star. Instead of a clean boundary, a defined edge where the planet ends, there is a gradual transition, where gas escapes, pulled into a structure that no longer belongs entirely to the planet itself. From a distance, it would not appear as a perfect sphere. It would look distorted, elongated, as if something is stretching it beyond its limits. The atmosphere, instead of surrounding the planet evenly, is extended into space, forming a kind of trail that follows the planet along its orbit. This is not temporary. It is continuous, driven by forces that do not weaken or pause. The planet cannot resist it. Gravity, which normally holds a planet together, is being overcome by the gravitational pull of the nearby star. The balance that defines a stable orbit still exists, but the internal structure of the planet is no longer able to maintain its integrity under those conditions. Material is constantly being lost. With each orbit, more of the atmosphere is drawn away, feeding into the surrounding space, gradually reducing what remains. The process is slow on the human timescale, but from the perspective of the planet, it is constant. There is no moment where it stops, no point where the planet regains what it has lost. It is not a cycle. It is a one-way process. From a human perspective, the most unsettling aspect is the loss of definition. On Earth, objects are defined by their boundaries. There is a clear distinction between what something is and what it is not. On WASP 12b, that distinction begins to disappear. The planet does not end cleanly. It fades into its surroundings, its material becoming part of something larger, something that no longer belongs to it. The idea of a planet as a contained object breaks down. Instead, it becomes something transitional, a structure in the process of being absorbed, where the line between planet and star becomes less clear over time. The environment is not just hostile. It is actively removing the conditions that allow the planet to exist as a separate entity. It is a world in the process of disappearing. Not suddenly, not through a single catastrophic event, but through a continuous transfer of material that slowly erases it. The closer it remains to its star, the more this process continues, until eventually, there may be nothing left that can be recognized as the planet that once existed there. And in that sense, it represents a different kind of end. Not an explosion, not a collapse, but a gradual merging, where one object loses itself completely to another, until the distinction between them is gone. Across all of these worlds, the pattern is difficult to ignore. None of them are simply more extreme versions of Earth. They are not places where the same rules apply under harsher conditions. They are places where the rules themselves begin to shift, where light, motion, structure, and time stop behaving in ways that feel familiar or reliable. Some remove the ability to see. Others remove the ability to predict, to stand on something solid, to find direction, or to trust that anything will remain as it is. And in the most extreme cases, they remove the idea of a planet entirely, turning it into something unstable, temporary, or incomplete. What they reveal is not just how varied the universe is, but how narrow the conditions are that allow a world to feel understandable. Earth feels stable, because everything here aligns in a way that makes sense to us. Light behaves predictably. Surfaces remain solid. Time is marked by change that follows a pattern. But none of that is guaranteed. It is the result of very specific conditions that could easily have been different, and elsewhere they are. These worlds do not just challenge survival. They challenge the idea that a world should feel like anything at all.